All right, let's get into it. Today, we're going to build something that, seems pretty simple on the surface, a calculator. But we're going to peek under the hood and find some really elegant Python concepts. We're not just making any old calculator. We're making a smart one that can remember its last answer and chain calculations together.
So here's the big question, the core puzzle we're tackling. You've probably used a calculator on your phone or computer where you get an answer, and then you immediately use that answer in the next calculation. But how do you actually code that? How does the program hold on to that previous result? Well, that's exactly what we're going to figure out. So let's just walk through a really quick example. Picture this. Our user types in a simple calculation, 10 plus 5. The calculator does its thing, and boom, it spits out 15. Easy enough, right? But this is the crucial next step. This is where the magic happens. Instead of starting all over, the user wants to take that result, that 15, and right away multiply it by 3. Our program has to be smart enough to remember that 15 and use it as the new starting point. That's the cool feature we're building today. So, how do we actually build this thing? Well, like any good project, we're not going to try to do it all at once. We're going to start by laying the foundation, putting together all the essential pieces, one by one. First impressions matter, even for a simple tool that runs in the terminal. So we'll start with a fun little detail, a cool ASCII art logo. This is really just a multi-line string in Python, but hey, it gives our program a little bit of personality right from the start. Okay, next up, the real logic. We're going to define 4 super simple single-purpose functions, one for adding, one for subtracting. You get the idea. Now, the most important detail here, the key takeaway, is that each of these functions returns the result. It doesn't just print it. That return is absolutely crucial for letting us grab the answer and use it in the next step. All right, now for the real aha moment of this whole project. We've got our math functions, but how do we connect the user's input, like when they type a plus symbol, to the right function? We could use a bunch of if statements, but there's a much more elegant, much more Pythonic way to do it. So, over on the left, you see the obvious way, a long, kind of clunky chain of if and elif statements. If the symbol is a plus, call add. If it's a minus, call subtract. I mean, it works, but it's messy and it's not very scalable. The Pythonic way, on the right, is so much cleaner. We just use a dictionary. This really cool technique is called dictionary dispatch. And honestly, the best way to think about it is like an old school telephone switchboard. The user's input, the symbol they type, is the key that tells the operator exactly which function to connect the call to. It's clean, it's super efficient, and it makes it incredibly easy to add new operations later on. And here is exactly what that looks like in the code. We create this dictionary called operations. The keys are just the text symbols the user is going to type, like the plus sign, and the values. Now, this is the really clever part. The values are the names of our functions themselves. Notice there are no parentheses after them. We are not calling the functions here. We are literally storing the functions as values in our dictionary, ready to be picked up and used whenever we need them. Okay, so we've got our logo, we've got our math logic, and we've got our dictionary switchboard. Now it is time to assemble all these pieces into the main engine that's going to run the whole show. The flow of our main calculator function is actually pretty logical. First, we get that initial number from the user. Then we kick off a loop that's just going to keep running as long as they want to keep calculating. Inside that loop, we ask for an operation and a second number. Then comes the magic part. We use our dictionary to find the right function, we call it to get the answer, and finally, we show the user the complete equation and the result.
Okay, I know what you're thinking. That all makes sense. But this brings us right back to our original question. We're in a loop, sure, but how do we actually pass the result of one calculation into the next one? What's the specific piece of code that does that?
Believe it or not, the solution is almost ridiculously simple. The entire magic trick of chaining these calculations together comes down to this one single line of code inside our loop. num1 equals answer. That's it. After each calculation, we just take the result, which we stored in answer, and assign it right back to our first number variable, num1. So just think about what that means for a second. When the user types y to continue, we just overwrite the old num1 with a brand new answer. Then the while loop runs again, but this time, the starting number for the next calculation is the result from the last one. It's such a simple update, but it powers our entire chaining feature. So that takes care of continuing. But what about the other option? What happens if the user types n because they're done with that chain and they want to start a completely new calculation totally from scratch. This is where we use another really powerful programming concept, recursion. Now, that might sound complicated, but in simple terms, recursion is just when a function calls itself. So to start our calculator all over again, we just have the calculator function call calculator. This basically ends the current session and kicks off a brand new one from the very beginning. It's a beautifully clean and simple way to reset the whole process.
So, as you can see, we didn't just build a calculator. We used a bunch of fundamental techniques that are useful in all kinds of programming projects. So let's just quickly recap the key skills you've picked up that you can add to your own toolkit.
Looking back, we've actually covered some really powerful ground. First, we learned to break a big problem down into small, manageable, single-purpose functions. Then we discovered the awesome power of dictionary dispatch to avoid those messy if-else chains. We used a simple while loop to create our core chaining feature just by updating a value with each pass. And finally, we used a little touch of recursion as an elegant way to restart the whole program. And that brings us to the end, but I really want to leave you with this thought. This dictionary dispatch trick is incredibly versatile. It is not just for calculators. I mean, imagine building a text-based adventure game where commands like go north or get sword map to specific functions. Or what about a data analysis tool where you can choose different ways to process your data? The possibilities are really endless. So the real question is, what are you going to build next?